so today we'd like to explain about center of mass.
Before going through it, we're going to talk about forces, mass, and weight.
Okay, so weight is the pull of the earth, or also known as the force of gravity. And also, force is the push or pull.
Both are measured in newtons, while mass is the measure of amount of matter an object has, and it is measured in kilograms.
Now we're going to talk about center of mass. So center of mass is the point where the mass is concentrated, so it will be balanced.
And it is also known as the center of gravity, even though the earth pulls at every point of it.
Okay, so we'll show you
how to measure the center of mass of an irregular object.
So we will need these things, which is the cardboard, an irregular shaped object. You can use lamina, but we'll use a cardboard. And we need to have a weight, an object to act as the weight, a pin to make the hole in the cardboard, the string for the plumb line, and the marker so we can measure where we will find the center of the mass.
So now we have already got our irregular object, which is cardboard, and we should mark each end. It's up to you actually, but we use 4 marks, which is A, B, C, and D.
So as you can see, this is the weight of the plumb line, and it will vertically, and the center of the mass will somewhere between this point and this point. And we will need to mark this point so we will know how the center of the mass. So as you can see, we've marked the line where the vertical plumb line is from B. Now we only need to do 3 more from A, C, and D.
AP.
So as you can see, we've now found the center of mass of the irregular object.
Okay. So guys, now we're gonna talk about toppling.
The position of the center of mass of a body affects whether or not it topples over easily. A body will topple when its vertical line falls outside its base.
So now stability is also a part of toppling, which I will talk about. So stability is the measure of how likely an object topples over when it is pushed or moved. And stability increases when we lower the center of mass and by increasing the area of its base.
There are 3 types of stability: stable equilibrium, unstable equilibrium, and neutral equilibrium. Stable equilibrium: when a body is displaced, it will return to its previous position. Unstable equilibrium, however, when a body is displaced, it will move farther away from its previous position.
While neutral equilibrium is when the position of the object is displaced, it will not move to the previous position, while it will be stayed in a new position in a flat surface.
For example, a double-decker bus is built to have a very low centre of mass and a wide base, so that the line of action of its weight stays within the base when it goes around a sharp corner. If something has a high centre of mass combined with a small base, then it's very unstable and will topple over with minimal effort. A plumb line is an example of a simple pendulum. All it consists of is a weight attached to a piece of string that can swing freely. The time taken for it to swing from one side to the other and back again is called the time period. The time period of a pendulum of the same length is always the same no matter what height you release it from, which is what makes them so good at keeping time. The time period and the frequency are related by the formula T = 1 over F.
So that's all for our explanation.
We hope that you get all the information you need.
Bye-bye.
Bye!